Human in the loop, or HITL, sounds like a concept that has already been solved. The AI does the heavy lifting, the humans come in and catch errors, and everyone's happy. Or is it? Research shows that only after as less as 15 minutes of viewing the AI's outputs, the human accuracy drops a significant percent, and it only gets worse with time. In this video, we are going to deep dive into what human in the loop actually is, the real version, not what the marketing version wants us to believe. We are going to look at a long session into the nuances of HITL, what the types of HITL, which of those types do we choose based on our use case, how and what can we do to prevent the human skill atrophy, and many more concepts. So this is going to be a long video, but if you want to understand HITL in depth, please stay along. So hi everyone, my name is Jayashree. I'm a senior product designer at Microsoft, and in this video we're going to do a little bit of a deep dive into HITL. So to start with, let's understand the agenda for our time together. So first we will look at what HITL is. Then we will dive a little bit into why do we need it in the first place? Are the AI systems not good enough by themselves? Then we'll look at the different spectrum of HITL. What are the different types and categories of HITL? We'll look at a little bit of theory and foundations, just so that our understanding of the core concepts is strong. We are going to be looking at about 5 to 6 different industry applications, the pros and cons of each. We are also going to understand the challenges and limitations of HITL. And then lastly, we'll look at the design cycle of HITL and what we as engineers can do, and what we as product builders can do, and keep in mind while we are designing these systems, and where do we add humans in the loop, so that the efficiency of both AI and humans is maintained, or at least increased. So to start with, human in the loop is a design paradigm in which a human judgment is formally embedded as a component within an automated AI-driven system. Rather than treating automation and human oversight as opposites of a spectrum, HITL treats them as collaborators, and each compensating for the other's specific failure modes. Now, what this means is that rather than looking at humans and AI as two pieces who can solve the job, so you either have a human do it, or maybe I can just use AI to completely automate it, HITL is a design paradigm in which we are looking at completing the task or the job with a collaboration of both human and the AI system together, in a way that each of these components' strengths are utilized and weaknesses are nullified. So let's say humans have a good judgment. They can add in a lot of context, a lot of gut feeling, if you may. But at the same time, humans may be slower in doing the task. Well, at the same time, AI systems are like super fast, but sometimes they may lack the apathy, they may lack the empathy, they might lack the context, they might lack the capacity to make that judgment. So HITL looks at a model in which both of these components, the human and the AI, can be paired together in a way that the task at hand is done, and the best of these both worlds are arranged in such a way that they work together. So in a nutshell, that is what HITL is. The next thing that we will look at is what are the three main components of an HITL, right? So HITL now describes any system in which a human provides an input, a feedback, or a decision authority at one or more points in an AI-driven process. So what is the role of a human? The role of a human is to either provide input, either provide feedback, or to provide the decision authority. In an AI-driven process, at any of these three stages. What are those three stages? You can have humans inputting their input, feedback, and decision authority during the AI training. You can have humans giving their input, feedback, or decision authority during the task, as in when it is happening. That is called as inference. Or you can have humans provide their input, feedback, and decision authority after the task is done. That is called governance. So again, just to make sure that the concepts are clear, HITL systems are looking at humans to provide input, feedback, or a decision authority into an AI-driven process during three steps: when it is being trained, when the process is happening, or after that when it is when we are looking at multiple different processes and trying to identify points in which we are making it better. So that is called as governance. Now, based on three things, so what we have seen is what HITL is. Now we're looking at what HITL is not. So it is not a rubber stamp. So there are a lot of required mandates, like required government mandates that need human in the system before the AI can before we can accept the AI's results. So we don't really add humans in the system just to get like that rubber stamp saying that yes, there was a human. So it's not a rubber stamp. It's not a safety guarantee. There are times when a human judgment, human inputs also fail. So it's not a safety guarantee. We still have to perform our safety checks. And it's not an assurance of the right answer. Humans can be wrong. AI can be wrong. Humans and AI both combined can be wrong. So it is also on product teams to make sure that the safety checks are properly made in place and not just rely on the human being in the loop to deduct that the system is safe. Similarly, we need to also have proper measures in place to make sure that the output of the AI plus human is correct and have checks and balances for that, rather than just assuming that because the humans and AI are now working together, the outputs are always correct. And lastly, it is not a fixed architecture. Just because we inputted or we placed humans inside an AI process at the beginning doesn't mean that 1 month down the line the same process still holds. Their AI systems and basically the way in which we do things generally is evolving at such a rapid rate that these processes might need upgradation every few weeks. Moving ahead, let's understand the need for a human in the loop at all. So are the AI systems not good enough or smart enough or fast enough, or have they not like learned enough to be able to do tasks by themselves? What is the need for human in the loop at all? Um, and I would agree on this a little bit, that maybe for tasks that don't have those many big consequences, maybe creation of a document or maybe creating an image, creating a video, we may not need a human in the loop at all. But for decisions that the AI is now taking that have consequences attached to it, that affect one or more people, one or more systems at large, and especially if the decisions are made at a large scale or a large speed, or if they have any risks associated with them, then we do need to add HITL in place. So AI systems are now making consequential decisions at scale, speed, and a level of opacity that makes the risks of inadequate human oversight qualitatively different from the previous tech eras. So the concept of human in the loop is not different, not new. It has been there since the age of automation, right? Since the age of industrialization. Remember those those pipelines, and they were the industries and the machines used to produce goods that used to come on that conveyor belt, and there used to be always humans standing there and identifying and picking and throwing out the damaged items, right? So the concept of human in the loop is not new. It's there from a long time. But right now, when we are seeing the scale at which AI systems are evolving, and the scale at which and the scale at which the decisions that an AI is taking, more often, more than years back, we need HITL systems in place today. especially when the cost of getting it wrong is huge, and especially when there are government regulated mandates placed on AI systems requiring them to have a human in the loop. So now that we have understood what HITL is and what are the needs for having an HITL, we'll now take a look at the HITL spectrum. What are the different types of human in the loops, and at what points can we use each of these? So think of it like a quadrant, right? So to start with, on the y-axis, we have high human authority on the top and low human authority in the bottom. And on the x-axis, we have HITL being placed after the AI process is done, that is the after action. And on the extreme left, we have HITL being placed before the action is happening. And in the center, we have HITL being placed during the action. So if we consider these two axes, we now have four different zones in which humans can be placed, and these need to be selected based on the activity that the AI is performing, based on the scale and impact of the AI decisions, right? So to start with, the first zone is the pre-approval mode, which is on the top left. So pre-approval mode is something that has very high authority, human authority, and it is done before the action takes place. Now, this is best used when the consequences or the severity of the AI's response is very high, where decisions are irreversible, where regulatory approval is required, or AI confidence calibration cannot be trusted. And for example, when you are training robots in surgery, or when you are scanning for when you're scanning mammograms or X-rays or whatnot, or where you have to make decisions that impact global climates or maybe some global movements. So at that time, this kind of human in the loop is suggested, where a human has a very high authority on the output or the response, and also the human is placed much before the AI action can happen, or much before in the AI action process. Also, some things to remember in the pre-approval mode are the human must approve each and every AI recommendation. The human always has the ability to override an AI recommendation. And we are also, so if AI recommends X and if the human recommends Y, we will have the time and the space and the opportunity to reverse that decision and course correct it. And also, it is also best for like high stakes and safety critical decisions. So this was the pre-approval mode. The second zone of the HITL is the supervisory mode. Now here, the humans are still in high authority on the top, but the involvement of the human comes in anywhere during the action or after the action has taken place. So here, human role is more to do with monitoring AI in real time. The human can override, can override or intervene the actions during execution. Humans are mainly responsible for preventing irreversible errors, and it's best for operational assistive style of human AI collaboration. Examples of this are air traffic control assistance, or maybe when you want to have autonomous vehicles, right? So when the car is driving, when there's an autonomous car and the car is driving itself, but there is still a human driver in the seat who is supervising that particular drive. So that is called as a supervisory mode, wherein the human is still in the high authority. They can easily override the AI, but they are not actively giving inputs at each stage. So only when it is required, the human will come in and step in and course correct the AI. And if you are a product person or if you're an engineer, it's best to use this model when you are when real-time monitoring is feasible for your particular product, when the operators have the training to intervene meaningfully, and when the most actions are reversible. Alrighty. So the next HITL type of HITL mode is the audit mode, wherein the action. So this particular thing happens during or after action, and there's a very less human authority because it has already happened after. So this is the audit mode, wherein the human now reviews AI decisions that have already been made. So that's post execution. The human cannot override or reverse decisions because they've already taken place. All they can do is learn from it and course correct the system so that next time they take proper decisions. It is basically not reversible. It just focuses on pattern detection and pattern correction. And it is also generally best for scalable oversight. So let's say that there are systems where you want to improve that systems over time. So at that model, it will be great to have an HITL in the audit mode. So this is best used for situations wherein you have content moderation audit queues. One example that I would also give later on in the presentation is about content and how AI is heavily being used to moderate content so that it can filter out all the bad players in the system who want to add content that's harmful. So it's not possible for a human to sit there and watch every video that's being uploaded to YouTube and Instagram at all times. In that case, an audit mode is good, where the humans can come in and do an audit and then help the system evolve over time. And we are Yeah, so this is the audit mode. And the next one is the fully automated mode, wherein the human has very low authority and it happens, the HITL happens either before or during action. So here the human role is almost no active involvement at all. The humans can trigger or intervene when there is an anomaly only. And then it's usually reversible because the humans can stop the AI only when there's an anomaly, and it is best for like low risk repetitive tasks. So, for example, spam filtering. For example, when there is an agent that auto completes tasks, right? Or when you're optimizing for chatbots on a website, or for some routine route optimization. So all these low risk tasks, they can fully be under automated mode, where a human can only step in if there is an absolute problem or an error. Uh, so now that we have seen four different types of HITLs, now let's try to understand what are the trade-offs. So with with AI, right? One of the best parts of AI is that they are able to execute things very fast at a scale. They are able to do things in just matter of minutes, which used to take months for humans to do alone. And when we are introducing a human in the loop, we are yes, we are definitely increasing the safety and the output of the decisions, but we are also increasing the time it would take for the task to be complete. We are also going to be increasing the human effort. So based on the type of task and the type of consequences the AI's decision will have, we'll have to carefully identify points in which it makes perfect sense for the product teams to include HITL into the AI process. HITL should not be included just for the sake of it, because it does add latency. But just because it adds latency, we should not completely disregard HITL, because it adds safety, and it ensures that whatever AI decisions are going to be taken, they are good. So the next thing that we will look at is the different types of industries in which HITL is currently there, and what are the pros and cons for each industry, right? So currently in healthcare, AI acts as a second reader for medical imaging. AI is doing a really good job to alert and review for clinical decision support. And especially in countries where not everyone has access to healthcare, AI is now being used to do the preliminary checks and identify cases that need a doctor or a medical intervention, and then helping those select people alone to get medical treatment. Some of the pros and cons of HITL in healthcare is that pros, definitely yes. AI reduces misfindings that the humans could have missed. AI enables primary care in remote areas. It definitely reduces time to diagnose on severe cases. And it's also helpful that the humans provide the clinical context or the patient's background or other things that the AI might not fully comprehend. So HITL works really good in healthcare, but there are some other things that we need to take care of, some of the cons, such as automation bias. Now, this has been studied thoroughly, and there is like a lot of research on this topic that says that a person who has been given a series of AI results, and if most of those results are correct, the human will subsequently loosen or lessen the way in which they uh, or maybe let me just put it in another way. So if the AI, if a human is presented with AI results, and if most of those results are correct, which is a sign of a good model, then the human starts believing and trusting more in the AI's decisions and trusting less in their own. So this is called as an automation bias, wherein just because the AI says it may be right. So there's a possibility that that can happen. There's also an alert fatigue, wherein if there are like too many cases being thrown at the human operator or the human in the middle, um, they could just have that alert fatigue. Skill atrophy risk. Now this is a big one, especially in healthcare. That means that let's say the AI systems are capable enough of handling all the regular cases, all the 80-90% of the regular cases that have good documentation, good medicines attached to it. And only the 5 to 10% complicated or rare cases are then assigned to human doctors, right? So at that point, there could be a slight atrophy in the skill of the doctors, where they might lose touch with how to handle the regular cases. So there can be a little bit of a skill atrophy, and we need to care and we need to design for that. And there's also a concept of liability ambiguity. So let's say that the human and the machine are together making a diagnosis, and who is liable when the diagnosis is incorrect, or there are consequences of an incorrect diagnosis. So there's also an ambiguity on who is to blame here? Does the AI will take the blame, or the human? Because they can say that the AI said so. So some cons in HITL in healthcare, that if we can design around this and if we can build systems that address these cons, AI in healthcare would be like really valuable. The second industry in which we are looking at HITL deployment is content moderation. And this is wherein the AIs will successfully or continuously scan content, freshly produced content on platforms such as Facebook, Meta, YouTube, or all other platforms where people do add content. There are some bad players in the system who would want to add content that's harmful to users, and it's not possible for humans to sit and watch those millions of videos being uploaded every minute. So at this time, we can build a tired AI human pipeline, wherein the AI, based on its model and training data, it will filter out all the bad player content, and then only flag or bringing the human wherein the AI is not able to understand if this is a good enough content to go, or if this needs to be filtered. The pros and cons of a human in the loop for content moderation are, pros, obviously, it can handle massive amounts of data. Scaling it is incredibly easier than what we would see if it was only a human. And having human in the loop would also add cultural and contextual nuances, because some type of videos may be okay in some part of the world, but the same type of video may be culturally completely inappropriate. So a human can add this type of judgment. Some cons in HITL in content moderation are there's a psychological harm to human reviewers, because the AI would only highlight cases that it itself is not able to modify or to categorize. And most often than not, these are these can have harm to psychological or have psychological harm to human reviewers. There's also a chance of content gaming by bad players. Maybe they can make content in such a way that it just passes the benchmark for an AI and then it gets approved. So there's a possibility of gaming the system as well. There's also a possibility of inconsistency in reviews by humans. So maybe one reviewer says, yeah, this is good, it's fine. Or maybe the other reviewer who is more stricter will say, this is not passing. And also there's a possibility, just like healthcare, that the human reviewers could receive a lot of alerts at scale, which can cause an alert fatigue. The next industry, and which is quite recent, but also a perfect example of human in the loop, is autonomous vehicles, wherein these systems require continuous active human monitoring, and human takes control of the system when there is a failure detection. So pros and cons of HITL in autonomous vehicles are humans can handle novel scenarios like traveling on a dirt a road that is filled with sand, or maybe there are some potholes, or any other data that's not or any other situation that's not covered by training data. It also provides legal accountability, that even though the AI is driving, the human is still sitting there and monitoring. So the accountability is with the human, and human interference can really prevent errors before they become fatal. The cons of HITL, and if you are a product person designing HITL, this is something that you should pay very close attention to, is cognitive vigilance, especially vigilance decrement. So there is research that proves that just after 15 minutes of observing the AI do its task, the human attention to that particular task decreases significantly, and after maybe 45 minutes, it's almost negligible. The second problem is the transition control. Let's say that AI is driving, and there's also another research that shows that for a human to come in and fully understand what's happening, and for them to get into that literally driver's mode, will take anywhere between 3 minutes plus and minus one. But sometimes the AI systems could hand over the transition that requires immediate attention. So at that point, how do we design systems that will help humans gain context of their surroundings, of the system within microseconds, and prevent casualties? Um, Also, just like how we saw in healthcare, there's also an automation complacency, complacency. I don't know. So this is when there is a disengage that happens when humans realize that AI is doing a really well job. It's driving by itself. So they tend to disengage, even though we feel that they are looking at the road and they are monitoring, but they start to cognitively disengage. So as product teams, if we can design around all of these cons, and understand that these all exist, but still if we can design around it to reduce the occurrence of these, this would inevitably give us better HITL systems. The other industry that is interesting in HITL is legal and judicial systems, wherein AI provides risk scores or document analysis like super fast, but the judge, authority, or the case worker makes the final determination. And this is really helpful because uh, firstly, the AI can do things very fast, right? What reading the documentation would have taken weeks, but the AI can do it for you, summarize for you within minutes. And AI could also surface factors that humans could overlook. AI could also surface patterns across other similar cases that would help in this case as well. So yes, there are advantages, but some of the disadvantages are algorithmic opacity, right? So let's say that the AI makes a particular risk score, or if it takes a particular decision or a suggestion. So judges are not really able to ask or question why it has come to that particular conclusion. What's the thought process behind it? So if you are a product team that's designing for legal and judicial systems, make sure you also add in the reasoning factor into it, so that the judges can also understand what is the POV of an AI system and where it is coming from. Some of the other industry applications, which I am not going to go into detail, but are equally important, are financial services. Who gets a loan versus who doesn't? Hiring and talent acquisition, resume screening, interviewing, scientific research, cybersecurity, education and adaptive learning. This is a brilliant use case. Machine translation and NLP. And there are many, many more of such use cases wherein having a human in the loop would not only prevent errors, but it would also benefit the whole AI process to become even more better. So just to have the list of advantages at a glance, this is more like a summary slide. First one is having human in the loop prevents errors. It's good for error correction. It helps human brings in the contextual judgment. It also helps the decisions be grounded in ethics. It builds legitimacy and trust. It also improves the AI system over time. That's the model improvement flywheel. It's also regulatory and mandatory that there is HITL, so that's a plus. It's also great at handling novel situations which the training model wouldn't have covered. And having human in the loop gives that accountability and auditability that many AI systems may or may not have as of today. But having said all that, there are also plenty of challenges with adding HITL in the loop, and we'll just discuss a few of these. The first is automation bias, and we have heard this term a lot in the past slides. So automation bias is humans systematically over rely on AI recommendations, especially when fatigued or time pressured. And a well-designed AI system with poor interface design can produce worse outcomes because the humans will start believing the AI more and more, especially even if it is wrong. The next challenge is throughput and latency. What this means is that human review introduces latency, that is time delay, that is incompatible with some real-time applications. Let's say, for example, if there is an emergency response that's needed, so at that point, waiting for 4 or 5 seconds for a human may not be the right thing. Again, there is cost associated with involving humans at scale, especially if you're thinking of like thousands and thousands of humans sitting there and monitoring the output. It might cost millions of dollars annually. The other challenges of HITL are inconsistency. Unless the humans are trained properly and they know what to expect and what not to expect, there can be inconsistency in their reviews. And this again will be fed into the models, and then the model may not really learn the right thing. And the next one is vigilance decrement. And this is something important that we heard of in the last slides also, that says that human monitoring performance degrades significantly within 15 to 30 minutes of sustained attention tasks. So how can we design around this so that the vigilance is maintained or improved, but not decreased? One thing that we saw with the healthcare system was the skill atrophy, wherein as what that means is that as AI handles routine cases, humans reviewers will only see difficult edge cases. Over time, they lose the calibration on routine cases types, and the skills needed to exercise independent judgment decreases, which again decreases the performance as an HITL as well. Some other challenges are responsibility diffusion. So who takes the onus of the action? Is it the human or the AI? And this is more important when there is moral or legal responsibility involved, such as legal and finance, all those fields. Um, and this is the last mile problem. So let's say that if the AI is able to handle 19 to 95% of the cases properly, only the most difficult ones come to the humans, which becomes increasingly difficult as time goes by and as AI improves. And lastly, we need to also ensure that HITL is not introduced into AI cycles just for the sake of it because it's a regulatory mandate. HITLs, when introduced, need to be put in places where the human input would actually make a difference. In the first step of the HITL design cycle, we are going to look at all the tasks. It's called as task decomposition. And what we're trying to do is we are considering the whole AI process, like end to end, and we are going to be decomposing that into smaller subtasks. And the aim of this step is to build a task compliance matrix. So what we do is we take all of those smaller tasks inside of the larger task, and then for each subtask that we have identified, we will we will gauge them across three parameters. The first parameter is AI tractability. Can the AI handle this reliably by itself? Then assign that a score. The second parameter is human value add. We identify or we ask ourselves, does the human judgment materially improve the outcomes? And then give that a particular number and then put it across each task. The third task is the consequence severity, and this is where the most HITL systems do come into play, is because of this factor. For each subtask, we ask what is the cost of error? What is the cost of the AI getting this wrong? Is it consequential? Is it really minimal? And then give it a score and do that particular thing for each subtask. So at the end of the step one, we should have a task compliancy matrix that assigns each subtask to an AI only or HITL or human only. So based on the scores that each of those subtasks get, we should be able to categorize them into, hey, these set of subtasks are good for AI only, these set of subtasks are good to have a human in the loop, and these set of subtasks are good if a human only does it. So that is the step one. The second step is the routing policy design, and this is where you will take in the different types of HITL that we have learned in the past, and we will try to understand at what points for each of the subtasks that we identified in the step one, where we're going to add HITL, which type of HITL do we need to add for each of these. And the third step is the interface design. Do you remember all the cons that we discussed about HITL systems and about like human atrophy, about alert fatigue? So now is the time when we are designing the interface for these HITL systems. So we need to design the human-facing interface in such a way that we are presenting AI confidence as a range instead of just uh, yes and no or a percentage. So let's present it as a range. We also provide explanations on why the AI has come to the decision that it has come to. And we also train the humans in the loop to understand these particular parameters and to understand and to let them know that it is okay for them to reject an AI suggestion. And also, we also limit the overall information that is displayed on the interface so that we avoid cognitively overloading the human in there. The fourth step is calibration and training. Now, this is where we are taking our humans who are supposed to be there in the loop and we are training them. We are training them on what are the different failure modes of AI. So not just AI can be wrong, but specifically how it fails. How would a failure state of an AI look? And what does the range of the scores or the range of the um, percentage of AI score that we spoke about in the interface design, right? So we also train them to know what each of these ranges mean and what it means for them and how they can comprehend each of these. And we will also train them on the override protocol. So what to do if the AI is not correct and if you want to override it, how can you do it efficiently, fastly, and quickly? And we also make sure that most of the humans, or at least all of the humans in the loop, have taken this particular training. They know how to act, when to act, where to act, and act in the best way possible. The last step is continuously track. Now, HITL is not just set it up once and forget kind of a system. Now, this is a system that needs to be regularly monitored, tweaked, changed even based on how it is performing. Because humans learn over time, AI gets better over time. Considering all these factors, it is best to have like a weekly or a bi-weekly monitoring sessions where we are continuously tracking parameters and identifying if the failure points, identifying the points at which the humans are course correcting stuff, or if both of them are doing the wrong things. So monitoring and feedback super essential, and that has to be done regularly. So final thoughts. Firstly, thanks for sticking around, and hope this has been helpful. But the whole goal of this presentation or this tutorial was to leave you with the concept that human in the loop is not a feature or not a checkbox or not a temporary bridge to until the full automation takes place. It's a fundamental design paradigm for any AI system operating in a consequential domain. So humans and AIs work best when they are involved, they are working together, and they're working together meaningfully with proper concrete boundaries on who does what and who can override what. So having said that, the question is not whether to involve human in AI systems, it is how to involve them meaningfully. I hope this tutorial has been helpful. I'm going to launch a few more videos where we are going to see the practical side of HITL applications. We'll take a few examples, maybe just spin up some code and see when and where to involve humans, how do we involve humans, and maybe even take a look at the interface design, the step 3, if you remember, and to see how an ideal design would look. So up until then, thanks for watching. If you have found this useful, please consider subscribing and do check out the other videos on my channel. Thank you.